In this lesson, we're going to start examining how we can work with rational functions. A rational function is any function that involves a fraction with variables on the bottom. So one of our parent functions, 1 over x, would be a rational function. Now the graphs of these are something we're going to spend way more time on next semester when you take higher functions, or next year in higher functions. For our purposes right now, we want to just deal with the algebra. It's complicated enough as it is. Our objective is going to be to simplify these rational expressions. Have one of them instead of having 2 or 3 of them. To do that, we want to use the idea of canceling. And by that I mean we want to divide things out. So like we do in fractions, just old fraction numbers, 15 over 20, we can cancel things out. We can simplify it. We can make it easier, make it smaller. 2 rules to be able to do that. Number 1, things have to appear on both the top and the bottom part of the fraction, and the terms must be multiplying together. So for example, if we were to take the number 15 over 20, now I know you guys know it's 3/4, but I hope you would agree that I can write 15 over 20 as 3 times 5 and 4 times 5. And our objective down the road with algebra is to notice that I have things that are multiplying on the top now. There's a little time sign here, right? And I have things that are on the top and the bottom that are the same. So what I can do with this idea is I can cancel a 5 with a 5. Because instead of multiplying both the top and the bottom by 5, I could just, it's the same operation twice, just cancel it out, and I can get 3/4 that way. Now that's a numerical example, which might make a little bit more sense. We're going to do down the road some algebra things, but we're really going to use the same ideas. I'm going to turn expressions into multiplying, and then going to cancel. Okay. So here's the numerical one. Let's see if we can get the idea of this. We can apply it to algebra things. Can I cancel? Our rules are I have to have multiplying, and I have to have the same thing on the top and the bottom. So 4 times 5 over 4. Is it multiplying on top? Sure it is. And the bottom, it's actually multiplying also. It's 4 times 1, even though we don't usually show the 1. So can I cancel? Yes, as long as I have the same things on the top and the bottom. And I do. The number 4 shows up in both places. So I'm left with just the number 5, and really it's 5 over 1, but we don't usually show that, so we say just 5. That's simpler than working through 4 times 5 is 20, and 20 divided by 4 is 5. It comes out to 5 anyways, right? But we're doing it in a faster way. Let's look at the next one. Negative 2 times 3 over 9. I have multiplying on top, but I don't have any of the same things. So I have to change the form of one of my expressions. Now I like the top. I can't really break the top down, but I hope you would agree I can change the bottom into 3 times 3. Now I have multiplying top and bottom. I have the same things on the top and the bottom. I can cancel them. I'm going to cancel 1 3 with 1 3. I cannot cancel both 3's from the bottom. Once I've canceled it, it's gone. Okay, so I'm left with negative 2 thirds. And if you don't really, it doesn't really make sense, you could have, yes, expanded this and said negative 6 ninths, which reduces to negative 2 thirds. But we're just going to try and approach it in a different way. Okay, if we look at the next one, you can maybe see why. I now have algebraic expressions. I'm going to apply the same things I do with numbers to what I'm going to do with variables and expressions. I need them to be multiplying, and I need the same thing on the top and the bottom. Okay, so if we look at this, obviously the top has multiplying. You can see there's a little multiplying right between these two brackets, right? The bottom itself is already multiplying. It's that times 1, just like we did in this example. We just don't usually show the 1, but there is multiplying there. So can I cancel? Yes. Things are multiplying. What can I cancel? I have to cancel things that are the same. Now I know some people are going to want to say, well, I can cancel an x with an x, and then a 4 with a 4, but you can't do that. And the reason why is this plus sign in the middle. We're only allowed to cancel things that are multiplying. I can't cancel the x or the 4 from the top because there's a plus sign between them. Instead, what I'm going to cancel is the entire expression. All of x plus 4, that entire bracket. Not separate parts, but the entire thing. Okay, because they're the same on the top and the bottom, the whole thing, and I'll be left with just x plus 3. And that's the big idea. Well, hey, we're not doing parts, we're doing entire expressions, and they have to be multiplying. And the common mistake is people start canceling parts, so just be careful. With that in mind, let's look at the next one. Why can this expression not be simplified any further? Why can I not cancel a 9 and the 3 and say, oh, that just makes 3? What's our rule? They have to be multiplying, right? And what do we have in this? We got a plus sign here. So I can't break parts. I can't break it into pieces and then cancel. I have to cancel entire expressions. So since there is no multiplying, there is no canceling. Or in our case, there's no simplifying. Okay, that's one of our big ideas. Let's look at some more. Sometimes you look at it and you say, well, there's nothing multiplying. I can't cancel. I can't simplify. But if I can turn something into multiplying, like we did with the numerical things, and we said 9 can be broken into 3 times 3, well, then we could cancel. Well, when we want to do that with algebraic expressions, what we're going to have to often do to turn things into multiplying is to factor things. A difference of squares looks like subtracting. But if I turn it into a factored form, now it's become multiplying. Right? This is multiplying. It's the whole idea of making factors. So things might not initially look like multiplying, but you can turn them into that by factoring. So let's look at our example here. I can't cancel anything right now. I only see plus and minus signs. There is no multiplying. But on the top, I can do a simple trinomial. What mans to this? X minus 3, x minus 4. On the bottom, we have a common factor. I can take a 5 out of both things. And now I've turned an expression that would look like adding and subtracting into things involving multiplying. I can cancel if the same things show up on the top and the bottom. So I'm going to take this entire bracket, cancel it out with this entire bracket. And what will I be left with? On the top, x minus 4, and on the bottom, 5. Okay, that's a big idea again. That's our second one. Okay, here's the last big idea. We're just going to do some examples. Rational expressions always refer back to that parent function, usually 1 over x. Okay. You might recall this function had a break in it. When we drew it, it was a weird one, right? It looked like this and looked like this. Okay. We said our domain was all real numbers except 0. And that's the big idea, because at 0, this function doesn't actually exist. So when we're dealing with rational expressions, we want to simplify them, we have to go back to this idea of at some points this function doesn't actually exist. We call this a restriction. And restrictions happen when you try to divide by 0. If I had the expression 1 over x and I put in the 0, I can't do that. This is not possible, right? That's a restriction. So when we're dealing with irrational expressions, we're going to have to make a list of restrictions where this function doesn't actually exist. Okay. To figure that out, you have to determine what values make the denominator, the bottom, equal to 0. Okay. That's what your restrictions are. And we have to do that before any canceling occurs, because sometimes our restrictions would disappear, and yet they are still part of the function because they were part of the original function, not the simplified one. Okay. So let's take a look at some of these things. I'm going to simplify and then I'm going to state restrictions, things that where this function doesn't actually exist. So here's a different one for us. Do I have anything that's multiplying in here? Well, when we write numbers and letters together, that signifies multiplying. So this entire expression is multiplying. So I can cancel things as long as they're the same on the top and the bottom. So for example, 24 and 16 are both divisible by 8. If I divide them both by 8, I get 3 over 2. I've canceled those. Right? I didn't show it, but I'm already thinking 8 times 3 and 8 times 2, and I'm going to cancel the 8s. Okay, we probably do the number parts in our head. With the letters, I notice I have x's on the top and x's on the bottom. I can cancel 3 of these x's with 3 of these x's, and I'll have 2 left over down here. If I do the same thing with the y's, 2 y's with 2 y's, I end up with a single y on top. And z's with z's, I'll end up with a z on top. So a better way of writing this would be 3yz over 2x squared. That's my simplified form. There's nothing left in there that can be broken down further. But also that's for restrictions. So what would make this equation not calculable? Well, if x was 0, I'm going to move down just for a second here, we'd end up with 3 times y times z over 2 times 0 squared. Well, that's like 3 times y times z over 0. I can't divide by 0. That's a restriction. So x can't be 0. I can see that right here. But the problem is, there used to be more things on the bottom. I just happen to cancel them out. If I go back up for a second, there used to be a y and a z on the bottom. And if I were to make y 0, way back up here in the question, let's put a 0 in here, 0 times anything is going to make a 0. That's a problem. So a restriction would also be y can't be 0, and similarly, z can't be 0. This function exists, this answer works, as long as x, y, and z aren't zeros. Then you can't calculate it. Yeah, that's our idea of restrictions. Let's try the next one. Can I cancel anything right now? I know somebody's tempted to cancel this 9a and the 3a and say that just makes 3. But we can't because things aren't multiplying yet. I have to make multiplying out of adding things before I can cancel. So we need to factor. That's common factor. On the top, I can take out a 3a. Now I've got multiplying. Things on the top and the bottom are the same. I can cancel all of this with all of this. What am I left with? A 2a plus a 3. Okay, and there is no fraction left because the bottom is a 1. When you divide by 1, it doesn't really do anything. Are there restrictions? Well, no, because down here we have this 1, but back here we used to have an a on the bottom. And if a happened to be 0, 3 times 0 makes 0, that creates a bottom value of 0. That's a problem. So a cannot be 0. Go back to before you cancel to check your restrictions. I'll try some more. Okay, at this point, I would pause and see if you can try them yourself and see what you got figured out. If not, check back. Okay, I see adding and subtracting. Let's turn it into multiplying. Let's common factor the top, and let's try common factoring the bottom. Oops, not 6. That would be a 3. Okay. The 2 and the 4 could definitely cancel those, right? They're both divisible by 2. So I end up with an x plus 3 over a 2 and a 3 minus x. Okay, I'm going to cancel this with this. Now, x plus 3 and 3 minus x, those seem awfully close to each other, right? But are they the same? Can I change the order and make them the same? Is x plus 3 the same as 3 plus x? Sure it is. And can I make these the same? No. 3 plus x and 3 minus x are going to be different things. So even though they have the same numbers and the same letters, and it's awfully tempting to cancel 3's and 3's and x's and x's, the expression itself is not the same. And remember, I need this entire thing to match with that entire thing to actually go further. So this one is as far as it can go. Don't forget restrictions though. Things that make the bottom equal 0. What would make the bottom equal 0? Well, I have to look at the variables. This equals 0 is a problem. So if I solve that, it tells me what my restriction is. In kind of the same way that we did quadratics last year, the restrictions are actually the zeros of the bottom. And sometimes we can look at them and just figure them out. Other times, like this case, maybe, you have to solve and say, well, what would make this equal 0? I don't want that, so let's solve it and figure out what makes that work. Okay? Let's try the next one. Adding and subtracting. Let's turn it into multiplying. That's factor. On the top, looks like a difference of squares. On the bottom, looks like a simple trinomial. Okay, so we're going to man that. I notice it's all multiplying now. I'm going to cancel entire expressions. I can do all of x plus 9 with all of x plus 9. I'll be left with an x minus 9 and an x minus 2. We cannot cancel the x's because it's back to adding and subtracting. We can't go factors, we can't go further. What are restrictions? What would make this bottom equal 0? Well, the obvious one is the number 2. Because if I were to put a 2 in here, 2 minus 2 equals 0. That's a problem, right? Okay. The other one has to go back to before I canceled. If I go back a line and say, well, this used to be on the bottom, what would make that become 0? X plus 9, it can't come out to 0, so x can't be negative 9. That's my second restriction, 2 and negative 9. But I have to go back to before I canceled. That was the key there. Okay, last question. Letter E. All kinds of good stuff in this one. Okay. Adding, subtracting. Let's turn into multiplying. Let's factor. On the top, we can common factor. X squared plus 4x plus 4. On the bottom, we can common factor. 3x cubed. X plus 2. On the top, inside the bracket, I can factor further. That looks like a different, a simple trinomial. So x plus 2 and x plus 2. On the bottom, I can't really go any further because I have no exponents. Okay, it's all turned into multiplying now. Let's start canceling. What can we cancel? I can cancel this expression with this expression. I can cancel one of these x's with one of these x's. I'll have 2 of them left. So what's my answer? 5, x plus 2 on top, 3, x squared on bottom. What are my restrictions? What makes x, the bottom become 0? Well, I can't have 0. It would be this one here, right? That's 0. And from up here, the opposite of that, can't have negative 2. Both those situations would create zeros on the bottom, and I don't want that. Okay, there's your rational expression, just the first day, but we're going to spend 4 days on this. We're going to keep adding in more and more operations between things. So we need to get the idea of just basic simplifying down first. Okay, for these questions, just try A, C, and E. If they don't have a letter E, then obviously you don't have to do those ones. Some of them are real quick, some of them take a little bit more practice. If you're stuck, come see me.